In this video, we're going to take a look at how our graphing calculators can help us with our quadratic regression. We have a study that some scientists did in Antarctica where they studied a species of grass to determine how efficient its photosynthesis process was at different temperatures. So our x value is the degrees Celsius in which they measured, and the y value was the efficiency of the photosynthesis. We are going to use our graphing calculator to input this data and then use it to help us determine what a good fit model would be. So there are two methods on how we can make sure that we can see our data, and the first one is that we look at our x and y values and we determine the smallest x value, and we go a little smaller than that, put that in our x-min, and then find the largest x value and go a little larger than that and put that in our x-max. We have a scale of 5 so they're not too bunched up. Same thing with the y values. We look at our y minimum, which in this case is 33, a little smaller than that, and our y max, which in this case is 95, and go a little larger than that. Since these values are more spread out, we have a y scale of 10 so that it's not so crowded on the axis, and you just leave the resolution alone. That's one way. The second way is once we have the data entered that we hit the zoom key and then press number 9 or use the arrow keys to scroll down to zoom stat and then hit enter. But before we do the zoom method, we have to make sure that we have our data into the calculator. So if you grab your calculator, make sure you turn it on, obviously, and in order to enter the data, we are going to press stat. Stat is 2 keys to the right of the green alpha key, so go ahead and press stat, then select edit by pressing enter, and we are going to put our information into our L1 and L2. Make sure that you put your x values into L1 and your y values into L2. This process is very important and it's very important to double check yourself, because if you make a mistake during this process, the entire thing can be affected. You may not get the right answers at all. So it's very important to make sure that you double check yourself after you have all your data entered. And the way I'm entering this data is I am pushing in the numbers and then pressing enter. I believe you can also press the down arrow, but I always like to press enter. And then once I have it done, I will double check to make sure that I do have the correct data in there, because like I said, one misstep here, one wrong data entry, and your whole problem is mixed up. So x values went in list 1, pressing enter after each one, and y values went in list 2, pressing enter after each one. The second thing I need to do is make sure my stat plot is on. So we are going to hit the second key and then y equals. We are going to then hit enter so we can look at just plot 1. Then you need to make sure that plot 1 is highlighted and the on is highlighted. If it is not, arrow to the on and press enter so it will be highlighted. Then make sure scatter plot is highlighted. Make sure you're grabbing data from list 1 and list 2, and make sure that this little mark of the square is highlighted so we can see it a little bit better. Once you've done this once, you won't have to do it again for different equations it will already be, or different data sets it will already be on. The next thing we're going to do is, if you set your window to the correct values, you can go ahead and just push graph, but if you did not, then what you are going to want to do is hit zoom and then number 9 for standard, and that will show us your graph. So if you had already changed your window values, just hit graph. If you had not, hit zoom 9, and then that will graph this. You should have this on the screen. If you did not get this, please press pause, go back and review the video. Make sure you're following the step-by-step instructions on your quadratic regression packet. If you do have this, then we're going to move on. We would also like, now that we have this data plot, this data plotted, we would like to see what the quadratic regression model's equation would look like. This would be a parabola or a quadratic equation of best fit. And it may not be exact, and we'll talk about how we'll know when it's not exact in a moment. But we can make the graphing calculator give us this equation. We don't actually have to do any work to get it ourselves, except to press a few buttons. So the first thing we're going to do is back to that stat button, which is 2 over from the green alpha button. Then we are going to arrow right until the calc is highlighted, and then we can either arrow down to quadreg and hit enter, or you can just hit the number 5 and quadreg should show up on your screen. Once that shows up on your screen, you're going to hit enter. Then you should get all this information. If you have one of the newer or one of the yellow calculators, you do the same thing, hit stat, go over to calculate, number 5 for quadreg, but notice that your screen looks a little bit different. What you need to do is arrow down to calculate and then hit enter, and you should get the same information. Now, some of you may notice that your information only has the A, B, and C, and you don't have the R squared that I have on my screen. We do need to turn that on because that's our correlation coefficient, and it's very important. It's the value that tells us how close to perfect our model is. In order to turn that on, hit second and then the 0 key. Yes, the number 0. So hit second and then 0. You should see a catalog. You're going to hold your down arrow for a long time until you see the D's. Once you get close to the D's, start letting up and make sure your triangle is next to diagnostic on. Once you have your triangle next to diagnostic on, press enter, and then press enter again until it says done on your screen. When you have that done, go back into stat, arrow over to calc, number 5 for quadreg, enter again, and then you should have the exact same thing that you see on my screen. Now once your diagnostics are on, you'll never have to turn them on again. They'll be on until you go back in and turn the diagnostics off or you reset your calculator for some reason. This R squared value is very important. Like I said, that is our correlation coefficient. That is telling us how exact our model is. Notice we have a 0.956. The closer that number is to 1, the closer our model is to hitting all of our data points. It's not very often that you'll have it at 1 for a set of data, but if you do, then you have a perfect model. Now, we can write the equation for this because, see, it says y equals ax squared plus bx plus c. It would say y equals, and then we would input this number for a. So it would say y equals negative 0.24876126555x squared plus 6.76706594x plus 46.37050717. Does any of you want to actually write that all down and then put it into y equals? Me neither. Let's make our calculator do that work for us. So if you turn to the next page, the way we can make this information show up in our y equals so that then the calculator can graph it for us is we are going to press y equals. If you have any information in here, make sure to clear it. Then we're going to go to a new key called vars. It's right next to your clear key. Press vars. We are going to arrow down or just press number 5, but arrow down to number 5 and press enter, or press number 5 so you have statistics. Your screen should look just like mine. Then we are going to arrow right twice to EQ and hit, also make sure it says reg EQ. EQ, reg EQ. Hit enter, and then notice all of this information is now in your y equals. If you have one of the yellow calculators or one of the new ones, it's the same steps, except yours shows up a little bit differently. Notice you only have the last few numbers right here. The rest of it is over where this arrow is pointing. You just can't see it. It doesn't all show up on your screen. So the older calculators will show all of it. The yellow and new ones will just show the tail end of it. So now that we have our equation that we got from our stats, we can graph it along with our scatter plot by pressing graph. So now you can see how well this model is fitting. Notice it's hitting most of our data points, but not all of them, which is why we don't have a 1 on our R-squared value. It's very close to 1 because it's very close to our data points, but not quite. So we need to do some analysis now. The purpose for this problem was to figure out where the photosynthesis was most efficient. Now, if you think back to all the work that we've done with quadratics, you realize that most efficient, or anytime you're talking about the most or the greatest, that's usually going to mean that is at the maximum, or your vertex. So in order to find our vertex, again, our graphing calculator will do this for us. We don't have to do the opposite b over 2a, which would get a little crazy with all those decimals. So take your calculator and press the second key, and then we are going to hit trace, which gives us calculate. And then all of these different things do different operations for us. But what we're interested right now is where our photosynthesis is most efficient. So that would be at our maximum. So press 4. Now you'll notice you have a little flashing, I think it looks kind of like a spider, but he is flashing somewhere on your screen, and you can move him with your right and your left arrows. And on your screen right now it says left bound. So what the graphing calculator is wanting you to do right now is narrow down the information from the quadratic, because as we know, quadratics go on forever, so it wants us to narrow it down so it's not trying to find the maximum in all of that mess. So go somewhere to the left, right in here, of your vertex, and press enter. Then notice it says right bound. So now we're going to move our flashing spider over to the right, somewhere in here of our vertex, and then press enter again. So notice there he is, right bound, press enter. You'll notice these two little arrows show up on the screen. That's where your graphing calculator is going to look for the maximum, between those two arrows. And then it says guess. I don't feel like guessing. You can throw in a guess in there if you want, but if you don't feel like guessing, just press enter again, and notice it now says maximum. Your maximum occurs at 13.60 and 92.39. Well, what does that information mean? Well, if you remember back to our beginning, the X values were the temperature that the reading was taken at. So that means that at 13.6 degrees Celsius, the efficiency was 92.39% for photosynthesis. So our most efficient photosynthesis at 92.39% occurred at 13.6. So the answer to our question is that the most efficient photosynthesis is 92.39%. Thank you, and I hope that this has been informative, and if you have any questions, please review this video.